Right triangle trig. Again, this is the amount of trig you learn in geometry all in one day, and then we'll just build on it from here.
That cost him 10 things without trig?
Yeah. Yeah.
That was right.
All right. By labeling the sides and angles of a right triangle, notice this is for right triangles, we can define the 6 trig ratios. So notice on all of these, we're using angle A. We've got a capital letter here for the angles. We got lowercase letters for the sides. So starting with, these are just abbreviations. When it says SIN, that is the abbreviation for sine, SINE. COS is the abbreviation for cosine.
And tangent.
Tangent is the abbreviation for, TAN is the abbreviation for tangent. I don't know if you learned the reciprocal ones in geometry. Reciprocals are basically just these, but flipped over. Kind of. Okay. Again, these are called the reciprocals. I'm going to write that on the side. Reciprocals. Okay. The CSC, its full name is cosecant. Cosecant. Yeah. The SEC is just secant, no co. Secant. And then COT is, what do y'all think it is?
Cotangent?
Cotangent, yes. Cotangent is its full name. Okay. So when I talk about the sine of angle A, sine is the ratio using angle A of the side that's opposite of it compared to its hypotenuse. So sine is the opposite side of the angle compared to the hypotenuse of the right triangle. I'm just going to abbreviate opposite and hypotenuse. Opposite over hypotenuse. Cosine of angle A would be its adjacent side, the side right next to it, compared to the hypotenuse. There is. We'll get to it. Adjacent, again, I'm going to abbreviate ADJ compared to hypotenuse.
And then tangent.
Yes, tangent opposite over adjacent. Good memory. Opposite over adjacent. Now the ones on the right-hand side are reciprocals of their mates on the left. Cosecant is the reciprocal of sine. So cosecant is just flipped over sine. So it would be hypotenuse over opposite. Secant is the reciprocal of cosine. So it would be hypotenuse over the adjacent side. Okay, and then cotangent is the reciprocal of tangent, so it would be adjacent over opposite. Okay, and there is a little acronym that you might remember to remember the 3 basic ones. Anyone remember it? It is so good to, yes. Okay, so is SOH, so that stands for sine is opposite over hypotenuse. CAH stands for cosine is adjacent over hypotenuse, so ca. And then TOA, tangent is opposite over adjacent.
Mm-hmm.
Okay. So looking at our first one asks us to find the 6 trig ratios for angle. We got a little Greek letter here. Anyone know what Greek letter that is? It's theta, right? And it's just basically a variable. It's just a variable we're using Greek letters now. I guess we ran out of regular letters. Theta. Okay. So let's find the 6 trig ratios for angle theta and then find the measure of angle theta. Okay. So what we're going to do is we're going to be using angle theta as basically the reference angle for what is opposite, what is adjacent, what is hypotenuse. Okay, good. All right. All right. So I'm going to start with, we do need to find a missing side before we can find all of our 6 trig ratios. Since this is a right triangle, how would we find a missing side?
A squared.
Yep. Missing side. A squared plus B squared equals C squared, little Pythagorean theorem. This is also a Pythagorean triple that you could memorize. Okay. A and B are always the legs of the right triangle, so it's always going to be our missing side and 12. Well, not always the missing side, but C is always the hypotenuse of the right triangle. The longest, right. So I'm going to call that A squared plus 12 squared equals 13 squared. So A squared plus 144 equals 169. So what's A squared?
5.
A squared is 25, which means A is 5. Okay, so I'm going to label it over here. We know this side is 5. Now that we know that missing side, now we can go in and find our 6 trig ratios using theta as the angle that we're referring from. 6 trig ratios. Okay, I don't know why I put an N. It's not rations, it's ratios. All right, starting with sine of theta. Sine of theta, you draw theta just by like writing 0 and putting a line through it. Sine of theta. So using theta as the reference angle, we need to find sine, which is the opposite side over the hypotenuse. So that would be what over what? Opposite of theta over hypotenuse. 12 over 13, good. Okay. Cosine of theta will be its adjacent side, the side adjacent to this angle over the hypotenuse. Adjacent means right next to. 5 over 13. Okay. Tangent of theta. Tangent, remember, is the opposite side over the adjacent side. What? Screen pause? All right. Reconnect. All right. Tangent is the opposite side over the adjacent. So the side opposite from theta over the adjacent side would be 12 over 5. Good. And then our reciprocal trig ratios are just going to be for reciprocals of these. So remember, the reciprocal of sine is cosec, CSC of theta. So cosecant should just be the reciprocal of 12 over 13, which is 13 over 12. Okay. Secant is the reciprocal of cosine. So secant of theta should just be 5 over 13, but flipped over, so 13 over 5. Don't make these mixed numbers. Don't make them decimals. Just leave them as their weird little ratios. And then lastly, cotangent is the reciprocal of tangent. So it would be 5 over 12. Good. Okay. Last thing we were asked to do is to find the measure of angle theta. Now, unfortunately, we can't just subtract from 180 because we don't know that missing side or this missing angle over here. So what we can do is we can use something called an inverse trig ratio. Not a reciprocal, but an inverse trig ratio. So first thing I want to do is I want to choose one of these 3 easy ones right here. It does not matter which one you want to choose, but I want to choose those because if we look at our calculator, let me kind of show you on the calculator. Calculator has sine, cosine, tangent buttons. Everybody see those on your calculator? Sine, cosine, tangent buttons. And then right above it, it has what looks like sine to the -1, cosine to the -1, tangent to the -1. And we know to the -1 we've already learned means what?
Reciprocal.
No. It means inverse. We learned that in almost every unit we've done this year. So the calculator can only do inverse sine, inverse cosine, or inverse tangent. It can't do inverses of these, so I'm not going to choose any of these. So we want to choose one of these to use. Which one y'all want to use? Doesn't matter. Ooh, a war. Oh, I heard 2 tangents. Okay. So here's how we're going to solve for our missing angle. All right, I'm going to write down that one trig ratio that we decided on as a team. We decided to use tangent of theta, which is 12 over 5. Okay. Now, to cancel this tangent right here, because we're trying to figure out what angle theta is. To cancel this tangent, the only thing that cancels tangent is inverse tangent. So I'm going to inverse tangent on this side to cancel this tangent. So if I inverse tangent on the left, where else I got to inverse tangent? On the right. So I need to inverse tangent on this side as well. Hold on. We're going to cross out tangent, inverse tangent, and we're left with theta equals. On the right side, now we have inverse tangent of 12/5. And here's where we're going to use our calculator. Now, first thing we want to always do on our calculator is we want to make sure our calculator is in degrees. Having math allergies. We want to make sure our calculator is in degrees. Because these angles are in degrees. You can literally see it marks right here. The default of your calculator is not degrees, though. The default of your calculator is radian measures, which are just a different unit. So we always want to switch it to degrees. So I'm going to write that here in big red letters. Calc must be in degrees.
Oh.
So how we do that is we're going to press the mode button on our calculator. Mode. We'll arrow down to where it switches radians to degrees. Radian, switch it over to degrees. Make sure you press enter so it actually switches to degrees. Now here's the annoying part. If you ever reset the RAM on your calculator, if you ever like push that little button on the back or second plus 9712, guess what it's going to go back to? Radian. Oh, that's something I would check on every time in this trig unit. Every day when you get here, calculator in degrees? Yes. Okay. All right, now my calculator is in degrees. So I'm going to go back just to my normal typing window now. And I want to use that tangent inverse button. So in order to access it, we have to press our blue button. Tangent inverse. So make sure it shows up with the to the -1 on your calculator. And then we'll type 12 divided by 5, or you can type the fancy fraction 12/5. And that should tell us that angle in degrees. Let's round to 2 decimal places, 67.38 degrees.
That was already three.
All right, let's look at the next one. Next one says to draw a triangle that have a hypotenuse of 7√5 units and a leg of 14 units. Okay, so I'm going to draw a right triangle. Got it. All right. To the best of my ability, I'm not trying to be a super artist over here. Here we go. There's a right triangle. It says the hypotenuse is 7√5. Remember, the hypotenuse is always going to be across from your right angle. And it says one leg is 14. It doesn't tell us whether it's the shortest or the longest. It just says one is 14. So I'm just going to pick a side to put it on. I'm just going to put it on this left side here. Okay. So the first question says, or not the first question, the first thing it asks us to do, it says determine the length of the other leg. Okay, so that'll be our step 1, is to solve for this missing side. Step 1, solve our missing side. Okay. Do you want to call this A or B? It doesn't matter. What? B? Too late. Someone said B. So we'll say A is 14, B is the one we don't know, and C, your hypotenuse is always going to be C. Yep, we'll do our Pythagorean theorem. We have our A squared plus our B squared equals our C squared. What's 14 squared? 196. I don't know why I wrote it 4. How do I square 7√5? Anyone know?
Well, you gotta find the number, and then you gotta multiply it.
Cool. What does that mean?
Okay, so it's gonna be 2.65.
No. What?
Equals
Square 7 and square root of 5. What's 7 squared? 49. What's square root of 5 squared? 5. All right. So then what's 49 times 5?
Oh,
What is it?
45.
145?
245.
Oh, okay. Sorry. You mumble, Paul. 245. Here's where we are. We got 196 plus b squared equals 245. What's my last step? Subtract 196 on both sides. That gives me b squared equals. Y'all all have calculators. 49. If b squared is 49, that means b is 7. Good job, Paul. All right, so we know our missing side now is a 7. And now let's read what it says now. It says determine the length of the other leg. Did it. And now we want to find the 6 trig ratios for the angle that's opposite of the shortest leg. So we know our shortest leg now is this 7. So the angle opposite of it is what we're going to be using as our reference angle. I'm going to call it theta. Or actually, we could just call it B. Since B was the side, we could call this angle B. Angle B. All right. So we're finding our 6 trig ratios using B as the angle. Trig ratios.
So is that low?
Okay, so I'm going to start with the sine of angle B. Sine would be the side opposite of it over its hypotenuse. Sine is opposite over hypotenuse. So we're going to write what over what? 7 over 7 root 5, which does simplify. Your 7's cancel. What else can simplify? Are we allowed to leave a square root on the bottom of a fraction? No. How do we cancel a square root on the bottom of a fraction?
Do it in square root of 5. Where is 5?
Yep. Square root of 5 on top and bottom. Yep. And you get square root of 5 over root 5 times root 5, which is square root of 25, which is 5. Do those 5's cancel? No. All right, so then next step, cosine of B. Cosine of B would be adjacent over hypotenuse. Yep. 14 over, I'm not good at writing numbers today, 7 root 5. Which can simplify a little, my 14 over 7. So that would leave me with 2 over root 5. And then what do I do with 2 over root 5? Yep. Do you remember what that process is called again when we multiply by that root 5 over root 5? Called rationalizing the denominator. Making it no longer a irrational number. So on the bottom, what are we going to have now? 5. Good. All right, we did sine, we did cosine, now up to tangent of angle B. Tangent, remember, it's opposite over adjacent. Pretty easy on this one. Opposite over adjacent.
Oh, 7.
7 over 14, which would turn into
1/2.
1/2. Okay, reciprocals now. Reciprocal of sine is which one again? Reciprocal of sine is, we wrote it up top. Reciprocal of sine is cosecant. Cosecant. This one is its reciprocal. Cosecant of B. Okay, here's what we're going to do. Instead of taking my final answer for sine and flipping it over, if I take this final answer and flip it over, guess what I'm going to have to do again? Rationalize it again. What we should do instead is take the one right before we rationalize, this 1 over root 5, and flip that one over. If I took 1 over root 5 and flipped it over, what would I get? Just root 5. And then I won't have to re-rationalize. So we just flipped over this 1 over root 5. Reciprocal of cosine is secant. Secant of B. Okay, this was my final answer, but I don't want to flip this part over. If I flip this over, I'm going to have to re-rationalize it. I want to take before we rationalize and flip this over. Root 5 over 2. And then we don't have to re-rationalize. And then reciprocal of tangent is, yep, cotangent of B would be just 2, because you'd flip over 1/2. All right, and then last thing it asks us to find, it says, what is the measure of that angle? So what would be the measure of B?
E.
MEAS, measure of B. Okay, so remember to find the measure of B, what we're going to do first is we're going to look at our 3 original trig ratio answers. And we need to choose one of these that we'll have to find the inverse of. Which one of these looks easiest to type into my calculator?
B.
1/2, right. So I'm going to write down tangent of B was 1/2. Tangent of B was 1/2. To solve for B, I need to cancel tangent. The only thing that cancels tangent is inverse tangent. So I need to inverse tangent on both sides. So on the left side, inverse tangent of tangent cancels. We're left with B equals whatever the inverse tangent of 1/2 is. And again, verify that your calculator is in degrees if you happen to reset it.
26.5.
Yes, 26.57 degrees.
Wasn't that so much fun?
Mm-hmm.
No. Already hard now.
It's not any harder than the one above it.
That was only over.
All right, flip it over. Let's see. Angle B in a right triangle has a sine value of 5/3. Find the cosine of angle B and the measure of angle B. Okay. Yes, it is easy. If they give you sine, they're telling you some measures on the triangle. So they're telling us the sine of B is √5/3. So that we know on that right triangle, the opposite side and the hypotenuse. Yep. Opposite and hypotenuse. Okay. So if our ending goal is to find cosine of angle B, we will need to know the adjacent side. So I'm going to draw this out first so I can think about it. Okay. I know my hypotenuse is 3. What side, what angle do y'all want to call B? You want to call it the top one or the bottom one? It doesn't matter. The bottom, oh, good idea. Yes. Okay, so we'll call this angle B. So then that gives me an idea of what my opposite side is. So you know the opposite side from B is √5. We do need to find the adjacent side though, because we're going to need that for cosine. Find adjacent side.
So we use a square root.
So a squared plus √5 squared equals my hypotenuse squared. What's √5 squared? 5. So that means a squared is 4, which means a is 2. Yay, a nice number.
Oh.
All right, we found our adjacent side, so now we can find the cosine of angle B. Cosine of B will be its adjacent over hypotenuse. So for angle B, what's its adjacent side?
It's 2.
It's 2. Over what's its hypotenuse?
3.
3.
So
Then last thing they asked us to do is find the measure of angle B. Again, to find the measure, you will have to use some sort of inverse trig function. So we can either do inverse sine or inverse cosine, whichever one looks easier to type in. Yeah, inverse cosine looks easier. Yep.
they all give you the same answer.
Find angle B. Okay, so we know the cosine of B is 2/3. So to find what the actual angle measure for B is, we need to cancel cosine. And what cancels cosine? Inverse cosine. And so I'm going to inverse cosine cancels it. We're left with B equals
28 plus 1.
The inverse cosine of 2/3. Again, if you have reset your calculator, make sure you go back to degrees. Yep, 48.19. I mean, we're rounding to 2 decimal places. 190.
Oh, yeah, you were. You sure go to it.
All right, last ones. We're given a right triangle, and we're asked to find any missing sides and angles. So not necessarily find all trig ratios, just find any missing sides and angles. This is what's called solving the triangle to find all the missing ones. Easiest thing to find would probably be what? A. Right.
Subtract.
Just subtract.
98 equal 148.
Okay. Angle A, we can use what's called triangle sum theorem, which is basically the fact that all three of these interior angles need to add up to 180. 58 plus A. So angle A is what? 32 degrees. Okay. That was our first missing piece of information.
Oh, no.
Okay. The next thing, do y'all want to find side A or side C next? It doesn't matter.
And let's see, using Pythagorean.
That's true. You have choices on that one. Okay, so let's find side A.
Sir. So once we use the cosine and opposite.
Okay, so to find side A, we're going to use one of our trig ratios. Okay, so if you want, you can start using angle A, and you can basically say, I'm looking for the side that's opposite of it, and I also know the adjacent side. If I'm looking for opposite, and I know adjacent, what trig ratio involves opposite and adjacent? Tangent, yes. So I'm going to write down, we know tangent of A is opposite over adjacent. Okay, I'm going to fill in what I know. So I know tangent, I know the angle is 32 degrees. The side opposite of it is what we don't know. I'm going to label that 8, and we know what the adjacent side is 14. So if I were trying to solve this little equation for the top of this fraction, what would I need to do to cancel the bottom? It's 5 by 14. And that gives me A equals whatever 14 times the tangent of 32 is. Notice this one is not inverse tangent of 32 degrees. This one's just a regular old tangent. 14 times regular tangent of 32 degrees, 8.75. Very good. So side A is 8.75. I'm going to call these inches since they labeled one of them.
Remember, we have all these solved.
Mm-hmm. To find side C, now you have options. To find side C, you could just do Pythagorean theorem, a squared plus b squared equals c squared. You could do another one of these tiny little trig equations where you're just solving for part of it. It doesn't really matter. Erica, do you want to use a little trig equation, or do you want to use Pythagorean theorem to find C? Trig equation?
Oh.
Bless you. Okay. All right. Trig equation. Let's see. We're looking for hypotenuse, so we could use any of the trig ratios that involve the hypotenuse. We know opposite and just solve for hypotenuse. Adjacent, solve for hypotenuse. It really doesn't matter. Which one did you use? Cosine? Okay. With A? Okay. So I'm going to say cosine of A is adjacent over hypotenuse. I'm going to fill in what I know. A is 32 degrees. Adjacent would be 14. Hypotenuse is the one that we're solving for. Notice the variable is in the denominator, so I'm just going to multiply by c to get it out of the denominator.
I'll divide it by 2.
Okay, and then I'm going to divide it by cosine of 32 to isolate that period. So that gives me side C equals whatever 14 divided by the cosine of 32 degree is. 14 divided by cosine of 32. 16.5. Those that use Pythagorean theorem, did you get around the same answer?
Yes,
16 and a half? Good, okay. 16 point, I'm going to call it 16.51. Again, for that last side, you'll always have kind of an option of how you want to solve it. What's that? Yeah. By thousands of years of mathematicians, yes. All right, again, we've got a triangle labeled for us already. We're asked to solve it, which means to solve for all the missing sides and angles. Can we start by solving for a missing angle? No, because we only know one angle. Oh, sorry, yes, you can't do triangle sum theorem, but if we know two sides, we could start by finding our third side. By doing what? Pythagorean theorem. Let's see, side B, a squared plus b squared, so that would be 21 squared plus b squared equals 26.4 squared. Let's see.
I'm slow down for you. Add instead of subtract, what we do?
Classic mistake. 26.4 squared minus 21 squared. And then don't forget to do the square root. So that'd be square root of 255 point what? 96. So, oh, well, that turned out nice. What should we round to? Yeah, we'll just call that 16. Well, yes, but rounding to 2 on this one, the 8 would bump the 9 up, the 9 will bump the next 9 up, and so it goes to 16. You could write 16.00 if it makes you feel better. B equals 16, and then these are in meters. All right. 16. And now we solve for one of the angles.
Solve for B and B with just a J hypotenuse. Opposite over hypotenuse, right?
B would be opposite. Yeah, you can do opposite over hypotenuse. You can do cosine adjacent over hypotenuse. It doesn't really matter. Do you want to solve for B first or A first?
Yeah.
B first? Okay. Angle B. Okay, so for angle B, again, since you know all three sides, it doesn't matter what trig ratio you use. You can do cosine, sine, tangent, any of the ones that we can do inverse for. Let's see. Honor, which one do you want to do? Sine, cosine, tangent? Sine. Okay, so we'll write down sine of B is opposite over hypotenuse. We'll fill in what we know, which we only know the opposite and the hypotenuse. No, opposite would be... No, what's the side opposite for B? 16.
Oh, we're looking at...
Okay. How would I isolate B?
You divide one multiply by
No. We want to isolate B.
by the inverse.
Yes, inverse. Good job. Those in the back know.
Oh.
Sine inverse on both sides. Yep, got to find the angle.
Not the other way around.
Yep.
You're finding the side, then you just keep the normal, right?
Yep. All right, so inverse sine, remember, don't forget to press seconds of 16 divided by 26.4. What'd y'all get?
37.31.
37.31. Bless you. Bless you.
You just subtract.
Yes, and then to find your last angle, you can just use triangle sum theorem, subtract from 180. My last angle would be angle A. Angle A would just be
The angle is
180 minus 90 minus the angle we just found, 37.31.
52.69.
52 point what?
69.
Alright.
21. This was 9 plays.
19.
She did not pass the vibe check.